We want to find the function which solves the initial value problem dy dx equals 3e to the x minus cosine x and y of 0 equals negative 1. Notice how the derivative function is a function of x. So to begin, we should recognize that we're looking for a function that has a derivative of 3e to the x minus cosine x, and we can find the function, or at least the family of functions, that have this derivative by integrating 3e to the x minus cosine x. And then we can find the value of c using y of 0 equals negative 1. This is actually the simplest type of differential equation that can be solved using a method called separation of variables. So if we know that dy dx equals 3e to the x minus cosine x, we know we'll have to integrate 3e to the x minus cosine x. But to show our work, let's write this differential equation in differential form so we can think of multiplying both sides of the equation by dx, which would give us differential y equals the quantity 3e to the x minus cosine x times dx, or times differential x. In this form, we can integrate both sides of the equation. So on the left, if it's helpful, we can think of this as the integral of 1 dy, and then we'll integrate the quantity 3e to the x minus cosine x with respect to x. The integral of 1 with respect to y would be y plus c, but since we'll have a plus c on the right, we'll just put the plus c on the right. So we'll write this as y, and then equals the antiderivative of 3e to the x minus cosine x with respect to x would be 3e to the x minus sine x, and then plus c. Because we have a function of x, let's write this as y of x equals 3e to the x minus sine x plus c. This is what's called the general solution, where we have a family of functions that have a derivative of 3e to the x minus cosine x. But because we're given the function value y of 0 equals negative 1, we can now find c, which will give us the particular solution, or the solution to this initial value problem. So we know that y of x equals 3e to the x minus sine x plus c. We also know y of 0 equals negative 1. So notice how this tells us the function value is negative 1 when the input, or x value, is 0. So by performing substitutions into our function, this would give us the equation negative 1 equals 3e to the 0 minus sine 0 plus c. This would give us negative 1 equals e to the 0 equals 1, so we have 3 times 1 or 3. Sine 0 is 0, so we just have plus c. Subtracting 3 on both sides gives us c equals negative 4, and therefore the particular solution, or the solution to this initial value problem, is y of x equals 3e to the x minus sine x minus 4. And again, this is called the particular solution. Now before we go, let's graph the slope field or direction field that would correspond to this differential equation, and then we'll also graph our solution on top of the direction field. So the direction field or slope field is graphed here in red. Y of 0 equals negative 1 corresponds to the point 0, negative 1 graphed here in green. And if we graph our solution, y equals 3e to the x minus sine x minus 4, first notice how it does pass through the point 0, negative 1, and also it fits nicely in the direction field, meaning the segments do seem to correspond to the slopes of the tangent lines of our function at any given point. I hope you found this helpful.